Hi everyone, it's Amira from Additive, and today I'm going to be presenting my Chartered Professional Review presentation. I did my review in 2022 and I did it online, so this presentation is going to be almost exactly the PowerPoint that I did on the day to my two reviewers. It's going to have the names of my colleagues and the companies I worked for redacted, but otherwise will be exactly the same. It was just under 15 minutes. In the review, if you go over 15 minutes, they do stop you. So it is worth trying to time it and practice it beforehand just to make sure you are under the 15 minutes. So I'm going to just go ahead, and if you like the video, please hit the like button and obviously ask any questions in the comments and I will get back to you. Good morning, Reviewer 1 and Reviewer 2. My name is Amira and I'll be conducting this short presentation for my Chartered Professional Review. I'll be presenting project name, one of the two projects mentioned in my professional review report. Project name, which is a joint venture between client 1 and other client, will produce approximately 650 new homes, with over 15% of these being affordable. Side by side here, you can see the existing site and the proposed superstructure blocks. And underneath these, we have a double-storey basement car park to the west of the site and a single-storey basement for the majority of the site, which will contain the new supermarket. Now, very briefly, on the existing site, which was previously a supermarket and a car park, there are a number of constraints. So there are two residential developments, one north and one south, railways on both eastern and western boundaries, and as I'll mention later, a 1.5 metre deep brick Thames water sewer running from west to east across the site. Now, this redevelopment project will enhance the local area by providing cycle links to improve accessibility to public transport, and a number of green spaces will also form part of the development with the aim of improving community wellness and cohesion, contributing to UNSDG Goal 3, so United Nations Sustainable Development Goals 3, good health and well-being. The larger commercial space will also provide employment opportunities, which refers to United Nations Goal 8, decent work and economic growth. So my role as an engineer enables progression towards these goals by designing safe and durable structures which allow these developments to benefit society. And I'll talk a little bit more about embodied carbon and my direct contribution to goals 11 and 12 later in the presentation. And the next slide shows the extent of the single and double storey basements I just talked about. They're labelled B2 and B1 respectively. Company were appointed as a consultant to client under a bespoke professional services contract. The client also had the role of principal designer and principal contractor as defined in the CDM regulations. On the left-hand side, you can see a project organogram, which showed the team I manage as project engineer and the teams I liaise with. And on the right-hand side are some key dates and project milestones, because these were the points where I found that the technical needs of my team changed alongside their needs from me as a manager. So taking stage 5 as an example, first thing I did was assess the capability of my design team in terms of the limits of their skills and knowledge. So one graduate in my team had never used the software for flat slab design before, and I provided that training personally as per ICE Code of Conduct Rule 5 to give all reasonable assistance to furthering the education, training and continued professional development of others. At stage 5, company were also contractually obliged to attend site every other week during the course of the works. So I took a leadership role to make sure that everyone in my team had CSCS accreditation for managers and professionals. That's the Construction Skills Certification Scheme. And I did this so they know about construction risks, which plays its part in improving standards and safety on site. As well as this, I assessed the limits of my own skill in managing companies' release of information at construction stage. And this involved reinforced concrete drawings, which both have a design aspect and a detailing aspect. Now, as an engineer, I'm aware how long it would take to design each element, but I did not know how long it would take to produce each drawing. And I knew that it would take longer based on element size and complexity, but I wasn't able to quantify that in terms of days and weeks. So I went through the construction program with the associate RC detailer, because that's his specialism, and I used his experience in mind to create a realistic program to manage internal resource, which would mean that we could meet our issue dates and meet the scope of companies' services under the contract. I managed companies' responsibility with regards to obligations the client had in third-party agreements, which involved producing multiple constraints plans at each boundary to show the existing and proposed sequence of works clearly. The client's party wall surveyor then assessed which works were notifiable to the adjoining owner under the Party Wall Act. So I worked with an external geotechnical engineer appointed by company as a sub-consultant to produce a ground movement assessment at each boundary to quantify the predicted movement to third-party assets. One example of this is the Thames Water Sewer, which is the red line running from west to east on that drawing. Because the site levels were lowered from the existing ground level by about 5 metres, and additionally the levels would breach the Thames Water Sewer surcharge level of 30 metres above ordnance datum, that 30 metres is based on Thames Water hydraulic modelling of the network. So I designed a structure over the sewer to confine it in a surcharge event, and this was part of the build-over agreement. My approach was to design length of one-way spanning slab, which spanned onto reinforced concrete capping beams, which were suspended between piles either side of the sewer. Now, where this wasn't possible, for example, where columns were positioned directly above the sewer, I had to use a reinforced concrete transfer beam to transfer those column loads onto the foundations either side of the exclusion zone. Those slab depths were governed by tensile forces, so a combination of surcharge loading and long-term heave loads, and the transfer beam depths were governed by the load on the columns coming down onto them. The pile spacing was generally governed by the tensile capacity of the piles. So to design the structure, I needed to understand the most onerous tensile and compressive load combination in both temporary and permanent loading conditions. Due to the excavation, long-term heave loads were generated due to the expansion of the London clay underneath, and the magnitude of that heave force was provided to me by the geotechnical engineer. Under CDM regulations, the designer has the responsibility to eliminate, reduce, and control foreseeable risk during the construction and maintenance of the project. So I've shown some examples alongside the hierarchy of risk management. So firstly, I've designed out heavy reinforcement in favour of lighter, smaller diameter reinforcement for the substructure, and that removes the risks of injury during installation. I've also designed out temporary propping along the western site boundary by using permanent buttress piles. Now, although this could be considered to be a cost saving, I also see this as an elimination of risk, because if you eliminate propping, you can reduce work in a space with other machinery, and then you can eliminate the risk of damage to those props and the associated stability of the wall. And where elimination was not possible, I've reduced excavation depths adjacent to the sewer by combining pile caps and reducing foundation depths. To control risks, I worked with the main contractor to define the scope and contents of the temporary works design brief for the crane bases to ensure that the correct design is carried out under the correct loading conditions and with the correct manufacturer's details. I've provided information on the risks in a clear and comprehensible way in risk registers like this, but also on drawings, so they are immediately available when someone is looking at the proposed works. Developing the information release schedule for this project was particularly constrained, as there was still outstanding information which would impact the substructure detailing. For example, loads from the test piles hadn't come back before I had to make this, which would affect the pile cap geometry and detailing, and therefore I had scheduled the vertical substructures, so the columns and walls, ahead of the pile caps, even though they wouldn't be required till later. On this document, the progress is tracked by the red line, and in purple you can see an allowance for a network rail review period for the capping beams and tower crane bases. In red are items for which information is outstanding and could incur a delay, so I tried to warn the client earlier in advance for items which would reach a delay. The process of developing this tracker was quite iterative because it was based on contractor priorities and commercial changes, which had to allow for time for the contractor to review drawings and prepare the site works. Any instruction by the client which resulted in a redesign, which was usually due to a late commercial decision, was something that I charged an additional fee for. So the format of this was an additional works form where the fees were calculated based on hourly rates and charged monthly based on the percentage of works complete. Recently, I've noticed there's been even more so an increased emphasis on cost. The inflation of construction material costs due to the pandemic caused the client to ask for more accurate reinforcement quantities prior to the issue of construction drawings, which is an unusual request. It also was the reason why the subcontractor changed between substructure phases. And this was because they couldn't absorb the flexibility in materials pricing, which was fluctuating so much. So since 2021, material prices have been affected by Brexit due to the increased administration of any material crossing the border. And there's also been an increase in fuel prices as a result of the war in Ukraine. So despite what I just spoke about with the IRS dates, we were still not hitting the internal targets for getting the drawings ready. And one of the reasons for that was because design mistakes were being spotted at approval level, which they really shouldn't be, because it should have been through thorough design and detailing checks before approval. I noticed that although we were complying with our existing quality management system, it wasn't prescriptive enough for what we were doing at stage 5. So I contributed to the improvement of QA systems by developing my own project-specific workflow. And I noticed the problem was occurring due to some neglect at the earlier design stage. And there was no way of recording that someone had checked a particular design and which iteration of the finite element model had been checked. So I created this document to document which revision of the model had been checked so it could be referred to in future. And also there would be some confidence in using the checked version of the model again. This also applied to calculations. Ed McCann discusses in his presidential address that 10 to 25% of construction costs goes towards fixing mistakes in a project, and this was my way of controlling the process to make sure the appropriate checks happen under my supervision. Sustainable management of resources is not only the fourth rule of the IC Code of Professional Conduct, it's also come to the forefront as the theme of Rachel Skinner's presidential address, where she talks about shaping zero. So one of the main points I understood from her was that it's imperative we all make our small actions towards net zero cumulatively if we're going to reach our 2050 climate promise. And that approach is where designers design more sustainably alongside using technology at its highest value. And in this project, I've contributed to the company's environmental management system by considering where I can design more sustainably. And for this, I took a two-pronged approach, considering both lean design and reuse. It's imperative to make a case for removing transfer structure where you don't need it, in my opinion, even though that changes the architectural grid. We can also think about reducing cantilevers, taking torsion out of elements to avoid torsional reinforcement, and spreading load so we don't need transverse reinforcement in walls. These are model screenshots where I used two different models in the same software to model the impact of transferring the stability system. Now, it was standard practice to model the structure above and below the slab in two separate models, but I learned how to model the transfer slab with the correct properties so you'd end up getting the right results at the foundation. And that improved design efficiency, and it enabled designers to do more with the available software. With regards to reuse, the curved pile wall you see in the picture buried under the site was proven to be durable for the building's future design life based on intrusive testing that I had specified, so this now became a feature of the site and a celebration of its history. We were also able to specify recycled and reused material to provide a more circular economy. For example, 75% GGBS, ground granulated blast furnace slag, as cement replacement for foundations, where cement production is actually a really large portion of the embodied carbon emissions which contribute to the concrete manufacturing process. Also, for me, the earlier you think about sustainability, the better. So when I was scheming a pedestrian bridge for the superstructure, I explicitly calculated the embodied carbon of my options to persuade the client to opt for a sustainable solution at the very beginning of the project, rather than our usual approach of looking at the damage once we've already made our design decisions. I think the main thing I've learned communication-wise and with regards to welfare through COVID is that there is no one-size-fits-all solution to how people responded and continue to respond to the pandemic. I changed the way I provided mentorship. I checked in a lot more when people were working from home, and I split hybrid working into tasks that you could do alone at home without too much input. And I arranged collaborative work in the office to optimize the time we spend together as a team. And I think our ability to do that as an industry made us really resilient to the pandemic, and I'm proud of what my team has achieved. Mental health, I think, became an increasingly important role in that isolation, and the IC Remote Seminar Archive was a hugely important tool for CPD during this time. I also worked with sites in the period before sites had to stop working to reassess their health and safety provisions. And it was really hard to get a sense of what was going on from site photos when you weren't actually there. And I had to settle with being taken around on someone's phone. But I think there are great developments in drone technology for other projects which are able to make use of that. I really enjoyed working in a mentorship capacity and also becoming involved with the institution as part of the ICE Women's Early Career Group. Further engagement with the institution is also something I want to do more of in future if I were to become chartered. So thank you for listening to my presentation, and I'm happy to take any questions. Thank you very much.